Okay, so I remember that the last class we had an issue with the let me finish it. Seems I didn't save. It's all good. Did not save. Okay, real quick. Yeah, we had an issue with the masters because every time we run this script, it's going to literally insert every single thing that we just claimed back to the master, which is not what we want. Now, to fix that, I'm going to go over to the folder. I think mine is in data analysis and look for Python, Python course and projects. Then let me just delete this masters data. I'm going to start from scratch. Now, to fix this little problem that I have, I will be needing to I need to incorporate some checks, right? I need to check every file if they have been cleaned before I clean. I will check if a file already exists in the master before I actually um, add it again, combine it again to my master. So let's do that. Now, one other thing I will add for the sake of documentation, so that when I run this code, it's going to be logging itself. It's going to have a memory, what it has done, what it's going to do. I'll be adding a login function, logs every action that goes on this code. So just a little bit of going to move this piece of code, right? I'm going to move it to top. I'll be using it for another action, another function. I'm just going to move it top. Let me just create a new cell here, do everything that I need. So I'll move this here so I get my today because I'll be using that a lot. That's why I'm creating it here. And one other thing I need, apart from the masters file, I will need a file called, let me move the masters file to the top. Everything is just in one place. It's, how did I create this? Bring the masters to the top as well. Because I will be needing this to check if a file is already in masters. Just move it just below this one, master file. Then I will also create a file called processed file. Processed underscore file is equals to, it should be inside of the base directory dash, let me just keep it in the base directory. The base directory slash processed, let's call this processed dash files dot x. Good. So we are going to read this file, figure out what files we've already processed. Now, let me use this. Now, apart from the process file and the masters file which I just added, I'll be adding in a log function that allows me to document every time I make changes to my code, it should be documented. So let me just create that function real quick. So before I do that, let me create a log file. I have a log file already. Don't just quickly create a log file. Log, no, log. So anything that any change I'm doing, I'm going to be adding it to the log file. So it's going to be called in log dash folder slash. So every log should have their own entry slash pipeline going to the name of the log file. So if I do something today, it should be stored on today's this log information. Do tomorrow should be stored on tomorrow's log. So this is log file. Pipeline dot date, today's date, then log. Now my log function, what my log function will do is this. Every time I carry out an action, I will print the action, then I will add it to my log file. What this does. So I'll say time. I need to do this again, probably. This time gives me the dates. Okay, let me just on for um dates day, blah blah blah. Dates today, dates time dot now. Dot string. So I'm basically combining these two together. So datetime dot today dot string formatting time. Then I'm going to adjust this. Just copy. Yeah, so I'm just putting it together. I'm combining all my string function, all my functions into one. So day, the month, then I need the hour, the month, minutes, sorry. I need normally goes like this, hour, minute, and percentage, second. So this is it. Year, month, day, hour, minute. Now, once I run this function, it's going to send a message. It's going to print this message. Message is first and foremost going to tell me the time this action was taken. Put this in square brackets. The time, then message. So for the sake of so I don't have any clash, I'll call this MSG. Call this print G. Right. Now write the message into my log file. This log file here. So open the function is a statement that allows you to a document apart from Excel, like a text file, a log file, any document that does not that Panda does not support. You're using the with open, and basically in the back end of Pandas, this is what happens. Use the it's open to read a file, then it now converts that file to CSV, arrange it in that data structure, does that for. That's what's basically happening back end. So I'll give it the encoding, going to be UTF-8. This is more universal encoding as file reads. And when it reads a file, what I want to be done to the file should write this message MSG plus plus button plus line. Right. So it's going to print, it's going to add that message and yeah, so let's give this a test. Let me up, run. Going to test this and see what it does. I'm going to call the log function, just pass a message, just any random message, hi there. If it works, okay. It tells me the time that the action took place, star hi there. So log file is not fine, sorry. It's supposed to be that. Let's try this. Good. Now it works. Let me go over to folder. I think it's somewhere here. I think I should add the log files to logs here. See if it's here. Okay, great. Today is 20, not 16. So let me see why it's not adding up. Add log file. Okay. Log folders like pipeline. Okay. Perfect. Worked. See why it isn't fresh. I'm looking for pipeline logs. Oh, right, let me see. Okay, let me run this again. It's supposed to do that. Okay, it isn't adding it. So let me see why. Right, a file dot write message plus line. Why isn't it working? Let's see. Right there. Right, let me see if I can fix this. Sorry, it's coming up. Okay, I think the reason that it's not working probably because I have not created this log file. Let me have a look. See, it's the case. Let me print this. Let me see what print bracket. Don't even middle part. Okay, data logs. Okay, okay. I know why that was the case. I think I know why that was the case. Looking at the wrong logs. So let me delete this. It. So it's this log. Good. So you can see it is working as it should. If I open this log over here, you can see its screen. So you can see the information, the action that I did, when I did first, when I did next, and so on and so forth. So we want to log every action we did so that we know in case there's a breakpoint, we know where that happened. So we're good on the log file. Good. Let's end this and pretty much open up a new file. So what else do we need to we create this processed? Okay, we have not yet, but we are going to do that now. Now we need to confirm if we have any existing data that we've cleaned already, right? So just load processed file. Now currently we don't have any processed, don't have anything on that process, which is what did I put? It's processed is a base directory process file. Base directory is right here. So right now, our processed file. I'm going to delete it, make sure it's empty. So we will build it again. Okay, let's get started. So we'll say if if processed, and see if we have a processed file. So this will help me check if I already have this processed file that exists. And this returns true or false. Now, if this is true, I want to create a new process. Open, then brackets, each, basically what we did here. I'm just going to copy this exact stuff using 80% of what is here to change what I need to change. So for this, we change this to processed file, right? Now, if we have a processed file, what we want to read it. We want to read what is inside of it. What is inside of it. Right. So let's try brackets. Now, once we open the process file, I want to save it as file. Now we need to do something with the process file. So we'll do test files is equals to a set of process, and that's a this without addition of process file. So file dot read function that allows you to process file dot split lines. So it's going to split the file by line. So each item will be separated by line. See what that is. Now, once that is done, do the else. Now, if we don't have a process file, we want to create a empty set. Tells us that we don't have any processed files. Okay, is equals to set empty. So now you can literally run this and see what this process file gives us. Okay. Now we have an empty set. Good. Now that we have this, when we are to make some adjustments our new file so that we don't accidentally add a process file to files we are extracting. Okay, that's what we do. So all files is now equals to new files equals to. Now this is what we do. We need to from this our all files. We need to remove our process files. It's all files, right? There are two ways we can do this, but we are going to use a simple or a shorter way, not necessarily the shortest way. So this is it. Say this is what we call a list comprehension. File or file in all files. So I'll show you what this is. So basically what this does is that it creates a list of all your files. This is already a list of all my files. So for the sake of simplicity, I'll just show you all of them side by side. So this is all files. So you have a list of all your files. 1, 2, 3, 4, and likes. Then right now, everything is going to basically be new files. Still going to be same as your all files. I will show you the difference when we run this a second time. Just note this down. Now, currently, it's not doing anything different. What I need to make this difference is that if a file name is equals to or is not in process files, not equals to, okay, I think nothing would be better because it checks for membership. So basically what this does is that it's going to go through all the files here and check if that file is not in this file, this one, that we just checked, then add it to my new files. That's basically what we are going to do. I'm going to leave this over here. That when I run this a second time, you see the difference. Good. So that's perfect. Now what we are going to do, I always said, we need to log the information. Okay. So we'll get an idea of what happened. Have a statement of what happened. So we'll say for this log, we'll say found. I'm going to count the numbers of items and brackets. So it's going to count the numbers of new files that I'm able to find. Bracket S. This is just syntax. Let's add a function that checks if it's yes or not. Okay. So that's cool. So let's move on. Now, there's something we can also do so that when it gets, okay, I don't think we need it right now, but let me just add it just in. So if new file now there's a concept in Python, right, that says that if a data type is empty, it is equals to false. Let me just show you real quick what I'm saying. Get here. Now, every data type can be translated. Let me use A is equals to 0, A is equals to 1, print. Now, every data type can be translated to another data type 90% of the time. Now, if you have a data type, let's say A, and you want to translate this to a Boolean, right, true or false, you can actually do that and translate it to a Boolean using the bool function, right? So A is equals to, yeah, you get false. Now, a rule that applies when you're translating this to Boolean is that every number is a Boolean except for 0. Every alphabet is a string except for an empty. Every alphabet is a Boolean. Like every string is a true. It's true except for empty string. This A is equals to an empty string. If I try to convert that to a Boolean, it's going to be false. If there was anything inside of here, it's going to be true. Right. So every string, when you convert it to Boolean, it becomes true, except for empty string. Then for your groups data, like list, tuple, dictionary, and sets, they are, if you translate them, if you convert them to Boolean, they will give you true, except for an empty version of that data type. So list, tuple, Boolean, list, tuple, dictionary, and set all evaluate to true if they have anything inside of them. Like for example, if this list has a single value inside of it, it becomes true. Now, this concept is very important when we start trying to carry out a conditional statement on a grouped data. Now, if I say if new list, say print hi, for example. Now, what happens with if? If does not work with um, numbers or any other data type. The if statement works with a condition. Now, the condition must evaluate to either true or false. So basically, your if statement must always work with a Boolean value. Now, if I pass a list, what does the if statement does? It implies that this is supposed to be a Boolean, and it actually tries its best to convert this answer to a Boolean. And according to what I just did just now, I said if a list is not empty, they evaluate to true. And if it is empty, they evaluate to false. Now, what I want to do is this. I want to check if this is my new list, right? This is my new file. If it is empty. And if it is empty, I want to stop my code from running. That's what I want to do. But there's no point in cleaning the data and inputting new data if there is nothing to clean and input, right? That's why I will need to do that. Now, if my list is empty, to give me true. If my list is empty, to give me false, and if it's not empty, to now to always use my to get the check if my list is not empty, I need to specify that not then open bracket, close bracket. So what happens is this to convert this to true or false, depending on if it's empty or not, negates it. So if it was empty, it's going to convert it to false, then this negates it to true because for if statement to work, the condition has to be literally be true for if statement to work. So this negates it to true if the list is empty, right? Then if the list is not empty, it's going to negate it from false. So whatever is here not be executed. So this is what I'm going to execute here. I'm going to first and foremost log this and no new file was no new file found or was found. Then I will tell Excel Python to exit stop run. Okay, good. Now that being done, I have this. Now the next thing for us to do is now that we have all of this, what we need to do is to go down our data because now we can actually check if we already process something that we don't actually process the same data multiple times. Good. Now the only thing I can do apart from that is see for data. Okay. I think I can clean this up a bit more. Clean this up a bit more. So I'm going to move this into this for loop. So it just does it automatically here. Okay. So I'm going to move all of this in here. This into my for loop. Okay. Copy this and bring. And something else I can also do in my for loop is a try and except statement. Now, what does that even so? You know when you run some code that has error, right? and your program automatically stop. Run a piece of code that generates an error. Let me just give you an example of what try. We have except, right? Have exception. Okay, so this is just try except block. So anytime you run a piece of code, let's say I write this, make it so that it fails. Now you have to put something like this. Yeah. Let's say I do something like this. Yeah. The code like this is going to fail because I didn't write it very well. Now, normally when this fails, everything else stops. But what I can do with try and accept is that I can anticipate this failure, right? I can anticipate it, and instead of everything to stop, I can say skip or something else. Like for example, I can just say, if this my operation does not work, then just tell me, just print something in your code fails, something your code failed. This seems a bit like if statement, but it's very, very different because if statement is you are the one that create the condition, but this only works if there's an error. It's an if statement, but it's particularly about errors. So let me just do this. So I think this worked. Okay, that worked. But okay, this doesn't work. This gives me an error. It's telling me that something in your code went bad. Same thing, I can write some random nonsense that you know is definitely going to be error. I run it. Instead of giving me the error, it gives me this something in your code wrong went bad. Now this is like a safeguard for your code so that when it experiences an error, it doesn't just crash. It can actually just do something else or stay on a idle position instead of just crashing and everything goes bad. So I'm going to incorporate this into this for loop. Right. The reason I'm doing that is because in case there's an error when I'm cleaning my data, I don't want it to spoil this other part of the. So let me just what I'm basically doing is I'm refactoring this code. I'm changing something. So let me quickly do that. So for this, I'm going to come over here and say try. So this is my try. To highlight all of this my other code and press tab. This try is supposed to be. Let me be very careful with this. Starting from here, highlight, tab. Good, perfect. Now the next is to come over here. I said I'm going to delete this because I'm going to work directly with the files. Work with the files. Great. So I'll say for data in new files, I'm going to delete this. So no need for this. I'm going to move this into, sorry, let's cut this. I'm going to move this into, don't really have a use for it right now. Same as this. We are going to move this straight in, yep, into the clean data right over here. Paste it. Okay, I still need to refactor one or two things here. So what I'm going to do is this. I'll say so for each item in I think I don't need rates. So for each data, let me change this to data. Great. So for data in all this, instead of data, I'm going to call this file. Perfect. So for file in new files, convert that file to data. File in new file, read that particular file, store it in data, then do your cleans on the data. Data. So everything else works. And one more thing we can actually do is this. For example, instead of writing this like this, I can come over here and log this instead. Just use the log function and boom, removed 3 rows and maybe file name as well. You can do this. File dot name, then column. So you have this. Okay, process comma this file dot name. If very good. Great. Okay, so file dot name and um removed rows moved is this rows. Okay, transformed all of this, and where did we what else did we handling missing data, fixing the text, fixing the SUK number. What else did we do? Great, this is fine. So we're going to add our except here. Except. So if we have a mistake, we do this. If when we are cleaning our data and there's an error, we will do this as E. Then I'm going to log the error. What error did we experience? Log that error. So error is equals to error processing. So if it processes one and it gets an error, it logs that error, it goes to the next one. In case there's an error processing one, it doesn't just break there, it goes to the next one. Try it's possible best to process that one. Processing. Wow. Then the error. Error. So this will now tell you the error that it experienced when you're trying to process that particular piece of code. Good. Now, don't need this anymore. So I have my cleaned data. I'm going to run this. Let's see if there's any error with this. So let's see. Argument. Error processing. So there's an error processing warehouse. Okay, I think let's see where the error is. So the error says log takes one position argument, but two were given. I think it's here. It's here. This is the problem. Right? This plus this. Let's try it again. Okay, good. No more errors. You see, it didn't break. It just showed me the error and I fixed it. So also this document is also going to be right over here in your logs. It's going to be on your logs, right? You can see everything that your code is doing. If I come back later, I can see where the code breaks and where it works. That's why I added the error, the log. Now, what else? Concatenate. Okay, good. Makes sense. Works. Got our code. Good. Um, Clean the data. Good. Good. So we have 9 something data. Now, what we are going to do as a final recourse, we are going to combine all of these. Let me call this projects. Projects for delta s Python projects. Okay. Okay. So what we are going to do is basically we are going to try to um, modularize this piece of code so that we can just execute it from anywhere, right? So we are going to try to. Now, this is basically limited to running on Jupyter. But what we need to make this work is to modularize it. Okay, so I'm going to quickly start. Okay, so we are basically almost done. Now, I don't actually need. One more thing I'm going to actually do is I need it. Okay, don't really need this anymore. So basically for the combine, I'm just gonna add a log message here that tells us I don't need it here. I need it here. Good, I need it here. So I'm going to log that the clean data has been successfully stored. Log. By clean. So I'll just put the amount of so cleaned data has been stored. Saved. Right. Then I'm going to put in the name of the clean data. So it's going to be, let me just leave it like that. Now we don't really need this as much. Now the next is okay. If data is, I'm going to log this as a message. If data actually exists, I'm going to log that as a so if we have our data, I'm going to log this. I can log this in. I'm going to log existing F, existing master records is length length master data, length of the master's data. Good. If that is if I have my master data, but if I don't, I'm going to log that master data set does not exist. Creating it. Good. So have I created? new data. This equals to master data. This do this. Uh, yeah. Okay, good. Okay. So same here. This is good. Good. Okay. If master data is not empty, master data is not empty, master data plus the new data, then if master data is empty, and if there is no master data, then master data is equal to new. But this is good. Now this will be a logged message. Log this in. Then I think that starts. Good. So once we're done with this, we're going to log this as well. That we are done with the master data. We logged it in. Log F. Only for the F scope, but I'm not really using F formatting. Master data set save. Great. Okay, now that we are done with that, the last step is to tell Python the file that we have processed. So let's just do that. Mark. This is the final step, and we are done with this. Mark files as processed. Great. So you say with open. So you are going to open up, going to check if the processed file, we're going to read it, see if it already exists. Now, if this A is that if it exists, A means all, means read and write, right? Read, write, create, basically anything about the phone. A will allow me to both read, write, and create. So if the file, the check, open the process file, we'll set the encoding to, now if you are an English, if you're using English, this would always work for you. UTF-8. For other language, it's going to be different as file. Now we are going to do this for processed. So basically, for all the files in view files, we are going to store them in our file, in our process file dot write brackets process name plus \n. So you get this. So write the name, the new line for each of the files here. So let me check my data. So this is going, process is stored. I think it should be stored here. Process should be stored here once it's done. So let's go through the data again and try it out again. Let's go. Run, 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 run. It cleaned, run, 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 run. Okay, I think I should also log this once it's done. Log pipeline, clean pipeline completed. Completed successfully. Great. Now also log this. Log F total master record is equals to is it should be here. Length in brackets master data. Okay, perfect. Good. Why am I having 680 something master data? Not supposed to be. Not supposed to be that. Probably made some mistake somewhere. Let me run this again. So I'm going to restart my kernel and do that kernel. Do this again. Let me go to data. Cleaned. I think it's under combine. I'm going to delete this current master data. So it's basically going to be almost like I'm starting from scratch. Then I will start my kernel. Then I'm going to delete the process data as well, process files as well. I think I have some process files already. This, Asaba Benin, okay, Benin Onitsha. Why am I having the same? Let's delete this. Let's see if everything works okay. Okay, good. Okay, let's restart our kernel, start kernel, and let's get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we're done. Now let's go. So now we have 309 rows. So I'm going to start again and try it again if it does anything. 1, 2, 3, 4. Now, did it see the, okay, these are process data. Good. Okay. Now for our new files, let's see what it gives us. It's not supposed, okay, perfect. It's doing its job correctly, right? If there is no new data, you should stop, right? You should stop the operation. And as you can see, there is no new, I've already processed all of this. So when I try to recreate it, it's going to tell me, no, it's going to stop the action. So this is perfect. Now, we are done with this. The final step is to make this a Python file. Right now, it is a Jupyter Notebook file. We can only execute this inside of Jupyter Notebook. What we want is a situation where I can automatically keep on executing this without having to come to Jupyter and try to do it manually. Go to the issue, then click. I get to the last one. So that's what I'm going to do. So let me just delete this, delete. Now to convert your Jupyter Notebook file to a, let me add Markdown, just at the speed mark of, let's call this Python project. to convert this to executable Python, we'll click on File, click on Save and Export Data, then you look for executable script. Wait for this to load. Once it's done, it's going to download. Once it's done downloading, we are going to move this. Where is it? Oh, fresh. But this is it. We are going to move this to our folder. It is here as well. Just paste here. Great. Now I can actually just right click, open a new. Let me see where we currently are. So this is in OneDrive, inside of desktop, inside of data analysis, inside of Python, inside of Python course. Then this is it. This is the one that we want. Good. Great. This is a Python file, completely executable Python. Now the only thing I'm going to do here is just to change the name. The name is a bit long. I'm just going to call it script. Or I'll call it pipeline script. Pipeline underscore .py. So this is an actual Python file that can be executed from anywhere. Good, perfect. Now, finally, before we end this, we are going to test that it actually works outside. So to test this, I will need to run Python from the PowerShell. Okay, close this. Come over to my download. There's the file just now. Fresh. Okay, this is it. Pipeline script. So I'm going to right click, open in terminal. It should pop up. And once this pop up, I'm going to do pip Python version to make sure that I have Python working on the background. Perfect. Now I will do Python and what's the name of this file? The pipeline script.py. Everything works. Okay. So it ran and it logged this out. No new files found. And this is where my code ends. Now I'm going to do a quick test to make sure that everything works. I will move a new one of this new data. One of them, just use this first one, and I'm going to move it to the clean, no, not the clean data, to the raw data. And I will run this test again. Python pipeline and press enter. Wait for it. Now you can see found one file. This is the reason I added the log because of this very thing. Most of the time, when you build your scripts, you won't be going through your Jupyter notebook. You're executing directly from here. So one file found, he added it, removed rows, claimed data has been saved, existing record this, remove one duplicate, master save, clean pipeline, total master record 26236. So you can see that it's not repeating the same data again. Now this is perfect. Now we are 95% done. The last thing we'll do is to set up a schedule that automatically cleans the data and store it in master, so we don't have to do it every time we need to. Now to do that, if you're using Windows, it's going to be reasonably very easy. So let's get started. So the first thing you do is to search for tax scheduler. Open that up. Now once you get start scheduler, right, the next thing to do is to create a basic tax. So you come over to the left, create basic tax. Then you give your tax a name. I'm going to call this pipeline, scripts. Now you can give extra description if you want, so I'm not going to do that. For my um, reoccurrence, I'll say daily or on log on. Once I log in my laptop, there's a lot of them when a specific event is logged, when the computer starts, one time, monthly, blah, blah, blah. I'm going to pick daily for now. So click on daily. So reoccurs every day, start time, this time. So for this, let me just change this to 12:50. Then synchronize across time zone. Go to next. Then start a program. Yes, we're going to click start a program. Click on next. Now, what program is it going to start? Now, this is very, very crucial. It's very, very crucial. We need to know, first and foremost, you need to know where Python is on your laptop. So to do that, you're going to go back to your terminal, which we played around with just now. You say Python dash where. This is it. Tell you where Python is on your laptop. The double dash one. Hold on, give me a second. Okay, let's try this since this isn't working. Is it up? Let me try where Python, see if that works. Okay, that did not work. We're going to try another thing. Let me think. Okay, this isn't working. So let me just try this. Python. Okay, now we're in Python. Then try this. Import system. Then print. System.executable. Okay, I've got what I need. This is what I need. Just going to copy this. Okay, great. Okay, so I'm going to move back to my scheduler and I'm going to paste this here. Good. And he said add an argument. So the argument we are going to add is this. We are going to add the file we want to run. That's going to be our argument. So we'll call this we're going to call this, what's the name of the file just now? Pipeline script dash script dot py. Now the next thing we need is this location, location of our folder. So I'm just going to copy it. My Python script is right here. The Python script. So I'm going to copy this, Control C, come over here and paste this here. So let's click on next and test it if it works. Every student, open the property dialog for task when click. Good. So with that, we are done with this. So let's see. Triggers, day by 4 p.m. Now you're done. This is going to trigger every day by 4 p.m. Now to see your tasks, let me come over here. See our tasks that we can also just click on run. Run it. It's going to open up a library and run. You see what it did? Literally, it was very fast, but he ran that and we didn't have any new folder, so nothing changed. So every time around 12, around 8:50, it's going to run this code and clean your data. Now that we are done, now to make sure that we are done with everything, we are going to do the final step, which is to upload our project to GitHub, right? So let's quickly do that. Now to upload this to GitHub, I need to remove any unnecessary folder like this. The reason I need is I think I'm just going to hide it. Let me go upload it to GitHub. So I need to zip this, then upload it to GitHub. Okay, so let me create a new folder and upload those to GitHub. So I will come over to project. It's going to be better. I'm going to move all of these projects. So view the project that I created, this guy, these, all of this goes to projects. So everything will be contained. Great. So we have 1, 2, 3, 4, 5. So everything works. So my stuff keep working. So my scheduler keep working. I'm going to edit it. I changed folder. I'm going to edit. Go to properties. Yep, properties. And I'm looking for the folder. Action. That program. Let me open this up. Okay. So I'm going to change the folder location again. So it still works. Just click, paste. Okay. Good. Good. Perfect. Now, to upload this to GitHub, I'm just going to, so you see, it's already exactly 5. It did what it's supposed to do, and it's done, right? So I think this is well supposed to be here, or it is added in here. That's perfect. That's actually perfect. Great. And I think I'm going to have a duplicate or something because of this process file that I did not add here as well. So probably we have a duplicate there. So I'm just going to delete this and delete clean. Delete all of this so everything looks fresh. Then fine this. So I'm going to run it again from the scheduler. In my logs, new data stays the same. My raw data. I'm going to move this away from here. Okay, great. So let me give this a new run. Right click and run. Okay, cool. Right click, run. Does its thing, and boom, it's done. And let's go back to code. Everything works. Let me check log. Log is back. The master data is back. The clean data is back. I deleted this one. I didn't that. But just to be safe, let me check my logs. The most important. See what actually happened. Okay. This is the data for it. Uh, good. Okay, I think this is it. Let me just do this again for good measure. We delete the clean. Just delete this, and this, and this for good measure. Let's see if it's still going to work. So let's try it again. Right click, run. Good, good, perfect, perfect. Let's see our in data. Everything perfect, perfect. 2 to 326, 2026. Did I not delete the raw data? Okay, I did not delete this, so that's why that was. So we get the idea. We are finally done. Now we are going to zip all of this. We're going to zip all of this. Projects, zip. We'll create a zip file for this. Okay, I don't think I will need to create a zip file. I don't need to create a zip file. Just okay, perfect. No need to create any zip file. Just come over here and go to GitHub, github.com. I'll see you in the next video. I'm going to do that in the next video.